Okay, guys. So I hope that you appreciate that's this resistor and it's in series with a capacitors. And the only reason you would get 9 marks in this question is because it's always happened with an AC power. There's nothing you need to do if it's a DC. So it's always AC, okay? Alternating currents. Because last lesson, if you were not here last lesson, that the components, the capacitors, has an impedance if you go from DC to AC. And so it's not called resistance, it's called impedance. So there will be a ZC, and then there will be a R resistance. So the total impedance is equal to, because it's in series, resistance add, yeah? So that's what we're trying to do for 9 marks, to work out what the total resistance in the whole network. But we call this impedance because we're dealing with an AC source. So it's the same thing. It's going to be measured in ohms. Okay, so I'm going to use a symbol ohms. So the thing is, so step 1, find the impedance slash, sometimes exam will call this reactance. Okay, so, or reactance of the capacitor. Okay, which is the ZC, yeah? Or in fact, so can you scribble this for me? Sorry, just use XC for now. XC, okay? So XC. Okay. XC on the formula sheets tells you this. If you look at the formula sheets, is, I hope you all still got your formula sheets because you need to take that off. Okay, so if you get your formula sheets out, anyone here not got a formula sheets yet? I gave it out in lessons, not during the test. So, okay, formula sheets. Okay. Yeah, so you can borrow it, but you need to take it if anyone not got a formula sheets. Okay. Shall I keep it? Yeah, those are spares. Okay, so in the formula sheets, can you find where it says reactance for the XC for the capacitor? Can you see where it is? I just need you to locate it. Good. What does it say? 1 over. Oh, someone say yes, but it's not a yes. Messing me up, man. Oh yeah, yeah, go on. So just go on. 1 over, exactly. So it's 1 over 2 pi FC. Okay. So can you do a little tick? Can you do a little tick on the formula sheets so you know you've done that? So can I just put some numbers in there? So I'm going to use a purple pen and then put, let's say 100 ohm here. And this capacitor, let's call that 5 microfarad. Okay, let's say 5 microfarad. So that means, what is the frequency of an AC coming out of a socket? That was a 12 marks question in the exam because people did not know. You're supposed to know what frequency is from this socket. It's standard. It has been around for almost 100 years. I know that's voltage. It's 240 volts or 230 volts. But what frequency is the AC waveform coming out? It's 50 hertz. Remember this, 50 hertz. So F is 50 hertz. Okay. So now I've got all my numbers. Okay. I hope you've got your calculators. So Now, if not, there's some at the front here. Just pass it on. Okay. So it's 1 divided by 2 pi multiply, and those people again, if you haven't been to a lot of my lessons, some of you have less than 50% attendance, then I use bracket to represent times. I don't write time sign at this level. So 50 hertz multiply by, and this is where a lot of you score low marks because you ignore the fact that it's micro. You must use SI units. So it's 5 times 10 to the power minus 6, guys. Some of you ignore the fact it's in millimeter. You're supposed to times 10 to the power minus 3. And all of you just put it as a number. You put 5 in it. Okay, that's why you score all no marks. So now you know this, you guys could have at least got another additional 6 marks, okay? To pass this exam, I think you got it backed up, but you just couldn't demonstrate that, okay? But there are a few other people who managed to actually did that, okay? But put the number wrong in the calculator or don't know how to use a calculator, okay? And got the wrong answer. So now, everybody, can you now put that in the calculator and see if you get the same answer as me, assuming I'm the one who knows how to do this. Okay, thank you. So it's 636.6197 like that. Okay. Another 3 marks lost in your exam because more all of you, in fact, only one person in this room only specify what you rounded to. Okay. Okay. I think Kai, I think I saw one you put like 3 significant figure or something. Now, here's the interesting thing is what do I round this to? Sir didn't never say to me, yes, I need to round, but what do I round it to? Well, no point do 3 significant figure because there's already 3-digit use. So I would do 2 decimal places. Look at this 9. Perfect. So I would say to the examiner, I'm going to round that to 6, 2, and then write 2 to the decimal place like that. Okay. What have I forgotten? I forgot to put the units. So the units for reactance is basically impedance, is in ohms. Okay? Reactance is measured in ohms. There are 3 questions in there that needs 1 mark for the for the unit. If you didn't know how to do it, you could have at least go around the paper and write down the unit for every single question. You could have got yourself 3 marks there. Okay? That's what I get my students to do at the end of the exam when they say only 5 minutes left. Just go through all your questions to see if you got units on. Okay? So those are just techniques. Right, I now know my XC. Okay? On here, okay, I haven't finished on this one. So before you add them, you have to square them and then square root it. What does this look like to you? Where have you seen this? Where would you square a square plus b square and then all square roots? When have you ever learned something that looks like this? Hmm? Pythagoras theorem. Yes, Pythagoras. Okay. Yes, you see, Kevin, you need him. Okay, so that's what we do is to find Pythagoras theorem. So this is where when we work out forces. So whenever we find the magnitude of something in physics, that's what we do. We add the 2 vectors together, square each of them, add them, square root it all. Okay, is that in the formula sheets? Is this in the formula sheets? So I gave out my copy so I haven't got any more space.
Oh yeah.
Can you tick that now, please? Yeah, it is. Yeah, you see. So xc square plus r square, all square root. Okay. So now take that. Okay.
It's the same one as the
Last page. Last page. Okay. Now step 2. Okay, so now we're going to find the total impedance. Now, what he might have got, he got my AAQ exam formula sheets maybe. So your might be slightly different page number, but it should be there. Find the total impedance. Z. Okay, so we write the formula out. Z is equal to square root of x. So it's the square root of xc squared plus r squared. So therefore, I put the numbers in now. So I put 636.62 squared plus, what's my r?
R is 100. I mean, 100 ohm.
It is 100, yes.
Yes.
Yes. And by this time, you already got 7 marks. Okay. So now, question is, have you got the answers right for your 8th mark and the units right for your 9th marks? Okay.
Wait, sir. What's the point of rounding? We're gonna put it back.
Oh, yeah. I didn't want to. I didn't want to go to that level, but I thought I'd go one step at a time. Yes, you're right. So what George is saying is, why are we rounding? Yeah, and that's why as European Space Agency, we couldn't land the rover onto the Mars because someone round the number too early, and then they put that number into the equations. So actually, I should be using this number because it's still on my calculator right now. Look, it's still on my calculator. So I'm going to square it, then add the 100 square and then square root. Okay, but exam in your case are very generous. They know some student would have rounded it, provided that they show they rounded it. You can actually substitute in there. Okay, so but in real life, as a proper engineer, if you're going to use this number again, don't round it. Carry on using this and round only at the end of your final answer. So therefore, you shouldn't show any rounding. Okay, so just bear that in mind. But I will reiterate this to everybody in the future. But for now, let me get you some marks first. So, and then again, I'd always like to show examiners some more working in case this is actually worth marks. So I write down what I got inside underneath my square root, and then it's quite a long digit. So I write this out, okay, like that. And then now I perform my square root of this, and then I'm getting Z is 644.25 dot dot dot, and then now I'm going to round that to 2 decimal place. Okay. If you're not used to teaching, being taught at GCSE to write lots of working out, now is your practice to start doing it. So, sorry guys, I forgot. I keep forgetting to do the unit first. So, and then round it to 2 decimal place. 2 student does not know how to round and roll 4 2. The 5 round up, yeah, because it's 5 6 7 8 and 9. Okay, so a lot of you, not just this group, the other group as well, did not know how to round. Although they say they rounded to 2 decimal place, they roll 4 2 instead of 4 3. Yeah, and that is actually a major mistake. Okay, so that's it. That's your 9 marks. Okay, done. All right. So, any questions?
So all you need to know is choose.
Yes, I say this. There is an ultimate one. The ultimate one, which happens 1.5 years ago for 15 marks on this question. And only 20% of the country actually did this. And I'm going to tell you what the UK have to find. They ask you to work out R. So therefore, they give you F and C, right? And they told you the impedance of the circuit, the total impedance. And then that's where people stop. They know this, they don't know how to rearrange these equations so that R is equal to. Okay, so let me just ask you this. Can you remember, if C is equal to A squared plus B squared, what would A equal to and B equal to? for the Pythagoras. Anyone remember? What's the equation? Yes, man. Is that what you said? So is the longer side minus the shorter side. Yeah? Like that. Like this. Okay? Now, if you don't know how to rearrange this, that's because you only memorize this, right? But actually, the formula is c squared. That's what Pythagoras actually said. He never said c is equal to square root. He said if you have the area of c is equal to the sum of the area of A plus the area of B. Okay, all right. So that's what it is. Okay. So if you have not been indulged by your math teacher, this is what happened. This is what Pythagoras said. He was looking at this right angle triangle, and then he called this C, he called this A, he called this B. And what he did was, he drew a square. And so therefore, this is C times C, right? So C squared. He drew a square here. So that would be A times A, so it will be A squared in the middle. And then he drew a square here. And then he said, that's B times B, B squared. So he said, the area of this is equal to the sum of those two areas. And he wrote that down. Then that way, using maths, you can square root both sides to find the length of C. That's what Pythagoras came up with. How to find the length of one side if you know the two other sides. But the actual thing that he came up with before Jesus was born, okay, was the area, okay. The people back in Roman time already knew maths beyond our modern days, but for some reason, maybe the war of 1,000 years, lots of things got lost. Okay, but they already invented lots of the maths that we might have already just recently found. So I just need to keep an eye on the CO2 level. So it needs to be under 700. Okay. So that's the difference between grade 7 students in maths and grade 4 students. Okay. So without knowing this knowledge, you are limited by relying on formulas. Okay. Right. Next one. So now it's in series with an inductor. Okay. What was my title before? So this time is inductor in series with a resistor. Okay. So this is a different one. So this time is inductor in series with a resistor. So once again, I bet some of you probably may be thinking, well, what happened if it's parallel? Yes, that's another circuit, but BTEC doesn't cover it. So in a way, you should be happy. Unless you, like me, pursue electronics engineering, then you will have to learn that as well. So it's a little bit, it's not that difficult, but I'm not going to explain those to confuse you even more. So again, we are doing this because it's an AC, okay? So resistor in series with an inductor. Look at how I draw the inductor. It's like loop like this. That's a symbol for inductors. And it's measured in Henry. Okay, it's a Henry. So this time let's put 4 nano Henry. Okay, and this one we're gonna stick to 100 ohm again. And then we're gonna go for frequency. What's the frequency again? 50, unless it actually specify. If they say to you it's a main power, then automatically you must know it's 50 hertz. That we actually complained to the exam board and said that that was a bit mean to not give that value out and assume students know it. But then they point out, well, we told you that in the textbook. It was in the textbook, but the teachers just didn't teach it. Okay, so many people couldn't answer this question. Okay, so this time the total impedance is equal to the square root of R square plus XL square. Okay, so again, go to your formula sheets and take that. So step 1 is to find the reactance. This XL is called reactance. So I'm just going to use a purple and say this is called a reactance, okay, of the inductor. So X is reserved, capital X is reserved for the reactance. Okay, is everybody still with me? Okay. So find the reactance XL first, yeah? Right? Right, look at the formula sheets. What's the inductive reactance? What's the inductive reactance? XL. What does XL equal to?
XL equals to 2 pi FL.
Exactly. No reciprocal. Just 2 pi FL. Easy. Okay? No more 1 divided by. Okay? Now, I'm going to give you a head start. I'm going to give you a minute. Can you work out what's... in fact, I'll write this out. I'll write the maths out first. 2 pi times by 50 hertz times by 4 times 10 to the power of... What's nano?
Minus 6.
No, micro is not. Micro was -6, guys. We just done micro. This is nano. -9. Yes, yes. Nanotechnology, even more smaller. Okay, it's good. You get it wrong, you always remember.
So this one,
So how do you remember?
The question is, can you still remember next Friday?
Which one is this one?
I can guarantee you, I'm going to make this happen. I'm actually going to tell you what topic's going to come up. Okay,
You
this
can tell
time,
us.
yes.
Remember.
Nano, yeah, N's for nano. Okay, so would you like? May I write some sort of for your reference? So I will start with the giga, G, giga. Okay, G is 10 to the power of 9. Mega, which is big capital M, is 10 to the power of 6. It's always multiple of 3's. And then, what's the next one? 1,000, which is, thank you, kilo. Okay, kilo. So kilo ohm. Okay, a lot of you did not do the 220 kilo ohm times it by 1,000. Okay, so honestly, you guys should have got at least 20 marks, easy. Okay, but next week you can demonstrate. And then obviously that's just units like ones, yeah. So now we go to milli. Sorry. So milli, which is little m. Okay. Is 10 to the power minus 3. And then micro, which is the mu, or sometimes because the people who type the letter don't have a mu sign, they use a u sign. Okay, so it could be or u. Okay, or sometimes they use just this u, so it's micro, which is -6. Then this is nano, which is little n, is 10 to the power -9. And then pico, which is p, 10 to the power -12. Okay,
And the answer, by the way, I got 1.256,37061.
Thank you very much.
Minus it.
Yes.
Wait, sir, you said it's always going to be that. Could they state otherwise?
Oh, that's what I just said. I said, yeah. Josh. It's okay. Yeah, unless they do sometimes say it's 5 hertz or 1000 hertz, then yes, you substitute. But that nasty exam worth 15 marks. They said that this is a mains power, so therefore they assume students should know it's 50 hertz. Yes. Yeah. So 20% of the country got. All right, so let me just finish doing the maths on this one. Instead of times 10 to the power minus 9, does anyone use the bottom now? I mean, obviously everyone. Does anyone use the EXP at the bottom? The EXP is basically your 10 to the power of. Okay, so if you might save your time. So I'm getting 1.2566 times 10 to the power minus 6. Yeah.
Yeah.
All right. Okay. So keep that on the calculator like that because you're going to square it, right? So now back to the impedance. Then are you okay? Are you all right? Good. Okay. What did I forget? I forgot to put ohms there. Okay. So step 2. Notice I'm not rounding this time. Okay. I'm keeping my numbers like this. So find the. What am I finding?
Find it out.
No.
The resistance.
R is already given to us.
Oh, you could.
Total impedance. We are finding the total impedance, not resistor. Total impedance of this whole circuit. Okay. So that means Z is equal to square root of R square plus XL square. So it's square root of 100 square plus 12566 times 10 to the power of minus 6 square. Right, here we go. So I square that first, then add the 100 square. And then I'm going to write, oh, very nice number.
100. That's what I like. Oh, I should get it. 1.3.
Bless you.
Well, I'm getting 10,000
Yeah, those have looked my 400.
square root. Yeah. So square root of 10,000 is 100. I haven't said no, George. Someone's talking to you. Okay. Someone else. A noise, a voice. Exactly. No rounding required. Okay. How interesting. Not a signal. No rounding at all. Okay. Now, so guys, I probably haven't explained really well what some of you probably still don't understand. What you've just done is to turn this 2 circuit in series into one resistor called 100 ohm. That's what we need to do, is to find out what the total impedance. So this is what you just found out. Okay, is to convert that into one single impedance. Okay. So that's it. So so now exam warning. So don't say I didn't say this before. So we could be asked to find R or L or C. Okay, you'll be asked to find any one of those. Okay, and then given the reactance and the total impedance. Okay, so just to show you, you can help me out as I do this, okay? So let's just say Z, so example, let's say Z total is equal to, let's do the capacitor one first, is equal to R square plus 1 over 2 pi F C. Make, so find F. Okay? When I say this, find F, that means you know every single letter except for F. Can you make F the subject of the formula? Okay, so find F. So so find F. So solution. Make F the subject of the formula. Now, I know a couple of you, I mean only a couple of you, know how to do this. So, but those couple of students hasn't got a really proper layout of a method. They eventually, through trial and error, they got the answers. So what I'm going to do is, I'm going to do it step by step with you, and then you're going to give me a hint what I'm going to do first. So what do you think I'm going to do to the equation first on both sides? What do you think I'm going to do? Yes, square, except, oh no, square, not square root, because I want to get rid of the square root. So I'm going to square both sides. So I'm going to write step 1, square both sides. So I'm going to write out in detail so then when you revise, you know what I'm actually doing. So I will have Z total square is equal to R square plus 1 over 2 pi F C. Is everybody happy with that? Yeah. Okay. What do you think I'm going to do next? Yes, you minus R square. Yes, so I'm going to use a different color pen to say what I'm doing to both sides. I'm going to do minus R square this side. I'm going to minus R square this side. Okay, we just moved too fast for some people. Okay, everybody happy? Okay, so now we're starting to eliminate a lot of terms on the right hand side. Now the terms are going to this side. Well, did we not just say Pythagoras? If you're looking for the shorter side, you have to subtract, right? So now I've got this. This is where people get stuck. They don't know how to do the next bit. How do you get rid of 1 over? What is the maths called to get rid of a reciprocal? In fact, you're kind of right. It's to do reciprocal again to both sides. If you reciprocal a reciprocal, you eliminate the reciprocal, isn't it? So, because if you say I'm reciprocating 1 over 4, it will become 4 over 1. Okay, so basically I'm switching both sides. Okay, so that means step 2. The wording is take reciprocal on both sides. Okay, so that means it will become 1 over zt square minus r square is equal to 2 pi f c, isn't it? Because you reciprocal that side, but on the right hand side, the reciprocal get cancelled. So there's no more 1 over. So 1 over that, sorry, it's happening again. So 1 over is actually called reciprocal. Okay, or if you like, 1 divided by something is called reciprocal. So now at this stage, you've got 2 options. Either know how to throw the 2 pi f to the other side, or do your maths here by substituting all your value. Let's say you got 10, and then it's 10 divided by 2 pi f. Okay, But how do I throw 2 pi f to this side? So now step 3, divide both sides. Oh, sorry, I'm making f the subject, isn't it? Divide both sides by 2 pi c. Yeah, because I can write 2 pi c f, couldn't I? Yeah, then I can treat this as one whole term. So it's timesing. So I'm going to divide this side by 2 pi f, 2 pi c. I must also divide this side by 2 pi c, right? Okay, so what would happen?
1/2 squared minus r.
Okay, I do this slowly, so not, okay, so I think some of you might get it. So I'm going to do it like this term, then divide by divide by 2 pi c, right? Is equal to f. Okay, that's it. You can just leave it like that. That's
Not hard.
yeah. If you because in algebra we don't like to use a divide sign. When you divide, you have to times. If you remember at school, fractions. So it will become. So I will put all. Okay. So it's to times by 1/2 pi c. Okay, which means you could simplify that because bottom denominator can times. So it's basically 1/zt square minus r square multiplied by 2 pi c is equal to f. Okay, but no, you basically you got all your numbers. Now you can substitute like that. Okay, so now last time it was the f. This time it could be the c. Okay, if it's a big marks question. So therefore you divide both sides by 2 pi f. Yeah, there is no way there will be a more difficult question than that. Okay, this is ultimately, it covers every angle, whatever the exam throw at you. Okay, so just remember, okay, mains power is 50 hertz. Okay, mains, it's got an S by the way, so it mains power.
So,
Yes, sir.
how many question really?
It was 15 marks. It was the last question of the exam. And one day I'll give you the past paper so you can have a go at it. So today we have take 3 equations. Yeah. All right. So plenary. Ready for this?
Yeah.
Okay. I would like you just to copy the circuit you just done with the inductor. Okay. Like this. How many nanofarad for Henry was it? 4, wasn't it? 4 nano Henry. 100 ohm. What if I ask you to find the current? Find the current. Can you find a formula near to the formulas you just ticked? Can someone read that formula out? Find the current. It's linked to reactance and resistance. So, can you see?
What equation?
The current. I want to find the current. Obviously, you know Ohm's law. I is equal to VR, right? but we're not dealing with DC here. This is DC. Is there a formula for the current?
Current.
I'm looking at it. I'm looking at it. I don't know why.
Yeah, I
Not,
found it.
what is it?
Is it the current slash electric flow? It's I equals G divided by T.
No,
Right.
because that would not be linked to inductors. Look, there's a formula there. I'm looking at it myself. It's right there.
No, this one's on the same page.
That's because you guys are looking for the word current. Do you know the symbol for current?
Yeah.
I equal to V over Z.
Oh, yeah. Literally.
Yes, I know. You were yeah. So I
No.
is equal to V over Z. Look what we've just done. We all through the lesson we were working out Z. So therefore, if I give this to you as 230 volt, right? You know its mains, and Kai already said the number was 230 volt. What's the impedance that we worked out for this circuit? Thank you. Yeah, someone's looking at the. We've just done it. We already worked out what the impedance of this is.
Oh,
Yeah, 100. Okay, so therefore it's 230 volts divided by 100. Yeah, so there will be a part C in an exam that asks you an extra thing to work out the current. Okay, I'll just 2 marks. Yeah, just gonna leave it. So therefore, basically what you've just done is you turn this circuit into just a Z component like that. So is V, yeah? And then you are asked to find the current I, so is V over Z. Because that, all this in series is equal to 100 ohm. So that is 100. And it's already given you the formula. Okay? All right? Look, that 2 marks could count between a merit. Maybe you are just 2 marks short from a distinction. Okay? Sometimes you never know. You'll be gutted if you're just that 2 marks. Okay, the world, you know, is sometimes it's just it just happens. Okay, that's it, guys. That's today's lesson.
Thank you.
Thank you.
Thank you, sir.